Good evening, sir. My name is C. Nikhila. I am from ECE department and my roll number is 234C1A0481. My assignment topic is collector to base bias. In this slide, I will explain about introduction to collector to base bias. Collector to base bias is a method used in transistor circuits. It establishes a stable operating point for transistor. Understanding this biasing technique is crucial for effective circuit design. Observe this circuit diagram. In this slide, I will explain about what is biasing. Biasing refers to the application of a DC voltage or current to a transistor. Proper biasing is essential for the linear operation of amplifiers. It ensures that the transistor remains in its active region during operation. Observe these circuit diagrams. An non-transistor with emitter bias polarities are reversed for a PNP transistors. Single subscripts indicate voltages with respect to ground. In this slide, I will explain about importance of biasing. Biasing is essential for ensuring that transistors operate in their active region. Proper biasing prevents distortion in amplification and maintains signal integrity. Collector to base bias is one method that provides temperature stability. Linear operation. Larger output has same shape as input except that it is inverted. Non-linear operation. Output voltage limit by cutoff. Non-linear operation. Output voltage limited by saturation. In this slide, I will explain about how collector to base bias works. In collector to base bias, the collector is directly connected to the base. This configuration allows for feedback that stabilizes the operating point. The feedback mechanism ensures that variation in current are minimized. Observe the circuit diagram. Base bias with collector feedback circuit. In this slide, I will explain about advantages of collector to base bias. It provides a stable operating point that is less sensitive to temperature changes. This method simplifies circuit design by reducing the number of required components. Collector to base bias is effective in achieving linear amplification. In this slide, I will explain about disadvantages of collector to base bias. One downside is that it may not be suitable for high frequency applications. The biasing can result in reduced gain compared to other methods. It may also lead to increased power consumption in certain scenarios. Observe this circuit diagram, collector to base bias method. In this slide, I will discuss about comparison with other biasing methods. Other population biasing methods include fixed bias and voltage divider bias. Each method has its own set of advantages and disadvantages. Understanding these differences is important for circuit design choices. First circuit base bias. Second circuit is collector to base bias. Third circuit is voltage divider bias. Figure comparison of similar base bias, collector to base bias and voltage divider bias circuits. In this slide, I will explain about temperature stability. Collector to base bias offers improved temperature stability compared to other methods. As temperature changes, the feedback mechanism adjusts the base point accordingly. This stability is crucial in applications exposed to varying environmental conditions. DIC is equals to minus RC by RB plus RC. Substituting dIB by dIC is equals to minus RC by RB plus RC. S is equals to 1 plus beta by 1 minus beta into dIB by dIC. Stability factor S is equals to 1 plus beta by 1 plus beta into RC by RB plus RC. Conclusion. Collector to base bias is an effective technique for stabilizing transistor operation. Understanding its principle is essential for electronics engineers. Continued research and innovation can enhance biasing methods for future technologies. Thank you, sir.